Welcome back to another video. In this episode, we are going to look at how we can find a trace of this particular matrix Q. What do we mean by trace? Trace is just is basically adding the leading diagonals, adding the elements in the leading diagonals. Okay, so trace is basically the sum of the leading diagonals. Okay, so that is basically the sum of the leading diagonals. So the trace of matrix Q, right, is equal to minus 16 plus 3 plus 1, and that is equal to minus 12. So that is the trace. So whenever you want to find the trace of a particular matrix, the trace is basically the sum of the main diagonals, the sum of the elements along the diagonal. So that is what we have here. -6, +3, and +1. So when you sum them, you have -12. Okay, so now once we know the trace, we want to find the determinant. Okay, so the determinant of matrix Q, along the rule 1, okay, we are going to have -16 into 3 to -1 1 minus, so minus becomes 12. Then we have 4 -3 -1 1 plus 5 4 -3 3 -2, right? So now we can see that the determinant of this matrix is equal to -16 into 3 plus 2 plus 12 into 4 minus 3 plus 5 into -8 plus 9, right? So we have the determinant of matrix Q is equal to -16 into 5 plus 12 into 1 plus 5 into 1. Okay, so when you sum everything here, you are going to have the determinant of matrix Q. The determinant of matrix Q is equal to +1. So that's the determinant. The determinant of matrix Q is equal to +1. Great. So we've learned the trace, we've learned the determinant from this matrix. Now we want to find the characteristic polynomial of the matrix Q. Okay, so the characteristic polynomial of this matrix Q is basically given by the characteristics of this matrix Q. You know, this is a 3 by 3 matrix. Okay, so the characteristics of this matrix Q, the characteristics polynomial. Okay, so that become SQ because it's a 3 by 3 matrix. So the degree should be 3 minus the trace, Okay, so minus the trace of Q, okay, and that becomes the coefficient of S squared. So we have S cubed minus the trace of Q, or X squared. Okay, then we take the sum of the minus of the matrix, the sum of the minus of the diagonal. Okay, so plus sum of the minus of the diagonals and that becomes your X. Okay, so we have this information. So this is how we find the the characteristic equation of a particular matrix. You check the size of the matrix, and that will help you know how to find the characteristic polynomial. So this is a 3 by 3. So the characteristic equation becomes s cubed minus the trace of that particular matrix, s squared, plus sum of the minus of the diagonals, and that becomes the coefficient of x. Nice. So let's proceed. You see, we have s cubed, we have s squared, we have x. Now minus the determinant of q. So that becomes the constant aspect. So minus the determinant of q, and that should be equal to 0. So this is the characteristic equation, the characteristic polynomial of this particular matrix. So once we have this data, we can go ahead and find them one by one. So now we have the trace of the matrix, we have the determinant. What is left is the sum of the minus. Okay, so the sum of the minus of the diagonals. So we have to find that once. So that becomes Q11, right? So Q11, we cover this element. That means first row, first column. So we cover this element here, cover this, and then we have this element. So that becomes 3, neg 2, neg 1, 1, right? So we have that to be 3 minus 2, and that is equal to 1. Q22, we cover this element, then we cover everything here, So we're going to have minus 16, minus 3, and then we have 5, 1, 5, 1. Okay, so here we are going to have minus 16 plus 15, right? So that is equal to minus 1. Okay, so the next one is Q33. So Q33, that is the third diagonal element. So that is this one. So we cover the one here. So when we cover that, then we are going to have cover this, cover everything here, So we have minus 16, 4, minus 12, 3, right? So this, when you do it, you're going to have minus 16 times 3. So 16 times 3, that will be 18 here. So we have 28. So we have minus 28. And then 4 times 12 is also 28 as well. So we have plus 28, right? Yes, so we have plus 28, and that is equal to 0. So we have the Q33 to be 0. So now we have the sum of the minus of the diagonals, right? So here we can say that our characteristic equation, or our characteristic polynomial of the matrix Q, the characteristic polynomial of matrix Q will be equal to s cubed minus trace of q. Trace of q was negative 12, so we have minus 12, so we have minus 12 s squared, then plus sum of the minus. So when we sum all this minus, we are going to have plus 1 minus 1 plus 0, and that's equal to 0. So the sum of the minus of the diagonal is 0x minus the determinant. Our determinant is also 1. So we have 1 here. So our characteristic polynomial becomes s cubed plus 12s squared minus 1. That is equal to 0. So that's our characteristic polynomial is s cubed plus 12s squared minus 1 equals 0. So ladies and gentlemen, this is the process that we go through to find the trace of a particular matrix, find the characteristic polynomial of a particular matrix. So first, if you want to find the trace of a particular matrix, the idea is that you sum all the main diagonals. You sum the diagonal elements. So if you have a 3 by 3 matrix, you know the diagonals are these elements. Okay, that is how you find trace. And over here, we had the trace to be minus 12. 2. If you want to find the characteristic polynomial, look at the size of the polynomial. Look at the size of the matrix. So here, the size of the matrix, the dimension is 3 by 3 dimension. So our first polynomial becomes x cubed minus the trace of the matrix, that is the trace of q, s squared. And we have the trace of q to be minus 12. So we have s cubed minus 12s squared. That becomes s cubed plus s squared plus the sum of the minus of the diagonal. So sum of the minus of the diagonal are the elements. So particularly when we are talking about characteristic polynomial and trace, we are focusing on the diagonal element. So the sum of the minus of the diagonal, meaning the first one, the Q11, you're going to cover the first main diagonal element, right? Then you find the determinant of the elements that are left, right? So when you cover this element, then you cover everything on that column, cover everything on that row. So we find the determinant of this, then we put it down. We had positive 1. Then you come down to find the determinant of this as well. So when you cover the second diagonal element, that is the 3. So you cover that, you cover everything on that column, cover everything on that row. So when you do that, you have minus 1. Then finally, you come to this final element on the main diagonal. So that is, you cover the 1 and cover everything on that row, cover everything on that column. So everything here becomes the element that you're going to find the determinant. So that also give us 0. So when we sum this, we had 0. So that is why we have the x section as 0. So basically, this is the characteristic polynomial of this particular matrix. S cubed plus 12s squared minus 1 equals 0. Ladies and gentlemen, thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'll give you more updates. Bye-bye.